Hello friends, now I would like to discuss about the term ligand, Ligand, ligand. So ligand is any chemical species. It may be negatively charged ion or it may be neutral molecule. These ligands they bond with metal parts, metal in the form of atom or metal in the form of ion. So this metal part, these ligand species get bonded to form a coordinate complex compound. So there is complex compound formation because of the combination of metal with ligand. So this ligand word is derived from the word ligare, Ligare. This is Greek word ligare. From this ligare word, ligand is derived. What is the meaning of this ligare or this ligand? Meaning is to get bonded with or to bond with, to get attached with, right? So from this ligand, we have to form different complex compounds. When we think about types of ligand, there are main three types of ligand: neutral ligands, then negatively charged ligands, and positively charged ligands. Among these, positively charged ligands are very few or very rare complex compounds are there formed by combination of metal with positively charged ligands. NO with positive charge, N2H5, that is hydrogenium ion with positive charge. These are examples of positively charged ligands. But when we see neutral ligands, there are various neutral ligands. Molecules such as ammonia, water, carbonyl, NH2OH. So these are examples of neutral ligands because they have no any charge on them. But there is presence of nitrogen or oxygen atom, and these atoms they bears lone pair of electrons, and this lone pair of electron is used to form bond between metal and themselves. So coordinate bond formation will be there because of the lone pair of electrons present on these atoms in these neutral ligand species. Here if we see about the negative ligands, negative ligand means they bears negative charge, they possesses negative charge. Chloride with negative charge, bromide with negative charge, iodide, nitrile, OH minus, NO2 minus, NO3 minus. So in all these species there is negative charge, and that's why they are called as negatively charged ligand species. So these negatively charged ligand species also bond with metal atom or metal ion to form a complex compound. So in this way, neutral ligands, negatively charged ligands or positively charged ligands, they bond with metal part to form a coordinate complex compound. Further, these ligands are again classified as monodentate ligand as well as polydentate ligands. Mono means only one. So those ligands which form only one bond with metal, they are known as monodentate ligand. And polydentate means they may be bidentate, tridentate, tetradentate, hexadentate, etc. So they are polydentate ligands. They can form bond more than one bond with metal part. Okay, that's why they are called as polydentate ligand. Example of monodentate ligand is ammonia molecule or H2O. H2O means aqua. So aqua and amine, these are examples of monodentate ligands. If we see oxalic acid, COH, that is oxalic acid. If we remove these two hydrogens from oxalic acid, it will convert into oxalate negatively charged ion, oxalate ion. So this COO, this oxalate anion, it can bond with metal through two bonds. First bond from this oxygen and second bond from this oxygen. So there will be two bond formations, TWO, two bonds will form there between metal and this. Only one molecule of oxalate ion. So oxalate can form two bonds. Similarly, if you think about EDTA, EDTA means ethylene diamine tetraacetic acid. For detailed structure, here Ca2 means ethylene. To this side Na2 group is there, to this side also Na2 group is here. So here ethylene diamine formation. Again, from this ethylene diamine we can get ethylene diamine tetraacetic acid. So here two hydrogens from this Na2 group, two hydrogens from this side Na2 group, if they are replaced by COOH groups, four carboxylate groups are bonded to these two nitrogens of amine group. So in this way ethylene diamine tetraacetic acid molecule or this compound will be formed. Now this ethylene diamine tetraacetic acid, it will convert into anion. How it will convert into anion? These two hydrogens and these two hydrogens, they will ionized or they will lost from this molecule, and here CO with negative charge, CO with negative charge, on this side also CO with negative charge, CO with negative charge. So this carboxylate ions will form here of this EDTA. So this is anion formation of EDTA. Now this anion species of EDTA will bond with metal. How it will bond with metal? This electron pair of nitrogen, it will donate it to this metal to form a coordinate bond. This CO with negative charge means this electron pair, it will donate to form bond with this metal. This CO with negative charge, that will also donate to this metal to form a coordinate bond. Similarly, from this side also three bonds will form with metal. So this one metal part is bonded with this EDTA anion through 6 bonds. There will be 6 bonds between this EDTA and metal. So in this way more than one bond will form, and that's why it is called as polydentate ligand. One molecule can form more than one bonds with metal. Such ligands are known as polydentate ligands. So after this there will be one more point, that is EAN rule, effective atomic number rule. What this rule suggests, if we think about K4Fe6, so this is a complex compound. When we think about this complex compound, Fe is the metal. Fe, that means iron is the metal, and iron has atomic number 26. But in this complex it is present in +2 oxidation state, so ferrous form. So Fe++ means, Fe2+ means after losing 2 electrons it will convert into Fe++ form. Fe atom will convert into Fe ion, that is ferrous ion, Fe++ ion, after losing 2 electrons from it. So originally there were 26 electrons with Fe atom, ion atom. When it converts into Fe++, 2 electrons will be lost, then remaining 24 electrons will be there with this Fe. Now these 24 electrons plus 12 electrons from this cyano ligand, nitrile ligand. 6 ligand means 12 electrons. Each ligand donates electron pair, that means it can donate 2 electrons. In this way 6 ligands, they can donate 12 electrons. So in this way 24 electrons of ferrous ion plus 12 electrons of donated by ligands, total 36 electrons are there. And 36 is atomic number of krypton, and krypton is a inert gas element. So during complex formation, metal atom or metal ion acquires atomic number to that of nearest inert gas element. So inert gas element may have 36 electrons, or they may have 86 electrons. So in this way, metal which is involved in the complex formation, that will acquire atomic number of next nearest inert gas element. Okay, so this is called as effective atomic number rule. Okay, so remaining part we will see in next lecture.